students, I am Latika Leekha. I am gold medalist in MPhil Mathematics and I have been associated with askIITians as mathematics faculty for the past 3 years. So now we will be beginning the chapter on trigonometry, in which we will basically be concentrating on compound angles as well as solution of triangle. So first of all, we will begin with what exactly do we mean by trigonometric function, and I am sure most of you must be having at least a rough idea about trigonometric functions. So we will discuss about graphs of trigonometric functions, and then we will be moving to trigonometry of compound angles. In compound angles, we will discuss various formulae like sin A plus B, sin A minus B, cos A plus B, cos A minus B, and so on. Then we shall also discuss various other formulae like Mn theorem, projection formula, sine rule, cosine rule, and various other formulas. So at the last, we will be concentrating on centroid and medians of triangle, and finally we will discuss cyclic quadrilateral and regular polygon. And once we finish up all these topics, we will be doing some of the IIT-JEE questions. So that was about this section, that is trigonometry. So in the first part, we will be concentrating on trigonometric function and the graphs of trigonometric functions. So let's begin. Hello students. So now we will be beginning the chapter on trigonometry, and in trigonometry we will basically be concentrating on the compound angles and the solution of triangle. So when I say trigonometry, first obviously we will discuss how did trigonometry come into our existence, or what do we mean by the word trigonometry, or how was this word actually introduced. So trigonometry can basically be thought of consisting of 3 words, or I can split this word trigonometry into 3 words: trigon, and then I can say metron, right? So tri basically means 3, all of you must be knowing, and then gon means sides, and metron means measure. So trigonometry basically means in ancient times also, in fact, the trigonometry was basically thought of, it was basically associated with the sides of triangle, or it defines relations between the elements of a triangle, right? Defines relations between elements of a triangle. So we know that when we talk of a triangle, basically there are 6 elements in a triangle, or there are 6 elements basically which define a triangle. That is, it has got 3 sides and 3 angles. So in trigonometry basically we talk of relations between the sides and angles, right? So let's begin. All of you must be having a fair idea of what exactly trigonometry means, or basic trigonometric ratios also. But even then, let's throw some light on the basic trigonometric ratios first, and then we'll move further. So basic definition of 6 trigonometric functions. The basic trigonometric functions that we have are sine, cos, tan, sec, cosec, and cot. So sine basically defines, here let me draw, this is the triangle suppose that I have. So this is called the base, this is 90-degree angle. Suppose this is the triangle ABC, then this will be the base, this will be the perpendicular, and this is the hypotenuse. So they are generally denoted by their letters P, B, H, respective letters. So we have perpendicular is this one, then we have hypotenuse, and then we have base. So sin theta defines perpendicular upon hypotenuse, then we have cos theta is base upon hypotenuse, tan theta is perpendicular upon base. Now sec theta is basically 1 by cos theta. So since cos theta was base upon hypotenuse, so sec theta is hypotenuse upon base. Now cosec theta is reciprocal of sin theta. So cosec theta is basically 1 upon sin theta, and therefore it is hypotenuse upon perpendicular. And similarly cot theta is the reciprocal of tan theta, and therefore it is base upon perpendicular. So and we have basic trigonometric identities also, like sin square theta plus cos square theta is 1 where theta belongs to R. This is the most basic identity, and it is often used in questions obviously. and then we have 1 plus tan square theta is sec square theta, or you can say sec square theta minus tan square theta is 1. Then we have 1 plus cot square theta is cosec square theta. These three are the most basic identities, and these should be on your fingertips obviously, and you won't have to in fact cram these identities, because as you solve questions they'll automatically be fit into your brain. Then we have sin 4 theta plus cos 4 theta is 1 minus 2 sin square theta cos square theta. Okay, now we have reduction formulae. That basically means, as you must be knowing, we have 4 quadrants. This is the first one, this is second, this is third, this is fourth, and all of you must be having a fair idea of these quadrants. In all 90 plus theta relations, that means suppose I have sine 90 plus theta, right? Then in this case sine changes to cos. This is something that you will have to remember. Sine changes to cos, and obviously then cos changes to sine. Then you have cosec changes to sec, and so sec changes to cosec. Then tan changes to cot, and cot changes to tan, and that happens only in case of 90 plus theta. This is important. 90 plus theta relations, the trigonometric function change, that is sine changes to cos, and obviously then cos changes to sine, and so on. And in case of 180 minus theta, the trigonometric function does not change, right? So if you have 180 minus something, 180 minus, suppose I have 50, then it will remain, the function will remain as it is. Sine remains sine, cos will remain cos, and so on. But obviously this will happen with appropriate signs. In both the cases it will happen with appropriate signs depending on the quadrant in which the function lies. So here we are just talking about the trigonometric function. I did not tell you about the sign. The sign will depend on the quadrant in which the function lies. Similarly, in case of 180 plus theta relations also, the trigonometric function does not change. So sine will remain sine, cos remains cos, tan remains tan, and so on. And this will also happen with appropriate sign. And in 2 pi minus theta relations also, that is 360 minus theta, trigonometric function does not change. This will also happen with appropriate sign, right? So you just need to remember, in case of 90 plus theta relations, trigonometric function changes, right? Then we have the graphs of trigonometric functions, right? So in case of graphs also, maybe some of you must be having a fair idea. When we have sine x, we want to draw the graph of y equal to sine x, then we'll have a graph of this form, right? This is the graph of sine x, in which at pi you will have sine theta, sine 180 is 0, so at this is p is pi, this is pi by 2, sine 90 is 1, so have here, and then we have sine pi is 0, then again sine 2 pi is also 0, so at 2 pi also it will cut the graph here, the graph will cut the axis here. So we have a graph of this form, and basically sine is a periodic function, so we have this form of graph, and it will continue like this, right? Similarly we have the graph of cos theta. In case of cos theta, now see, cos 0 is 1, so it starts from here, then it comes down, cos 90 is 0, so at pi by 2 we have it as 0, then again this is pi, so at cos pi is minus 1, so we have it here, then again it will continue like this, right? It will keep continuing like this, sorry, this will be here, then again it will go here, and similarly on this side also it continues like this. Similarly we have the graph of tan x, and in case of tan x you have it like this, since at tan 90, at tan pi by 2 is not defined, so we have it running parallel to pi by 2. Here it will continue like this, and similarly we have it like this. So this form of graph is of tan x. Then again you have it like this. Similarly we have the graph of sec, cosec, and cot. So in case of cosec x we have a graph of this form, right? again on the basis of same notions that we have just now discussed, explanation is same. Then we have cot x is like this, this, and it keeps running like this, and in case of sec x we have a graph of this form, right? Okay, now we have an example based on this, that prove that cos 10 plus cos 20 degree plus cos 30 degree plus so on, cos 80 degree plus cos 100 plus cos 150 plus cos 160 plus cos 170 is equal to 0. Okay, so how do we proceed? Now see, if you have questions, or whenever you have questions of this form, what we will do is, I am writing it like this. This is the given term, then I have cos 80, cos 100, cos 150, cos 160, cos 170 equal to 0. I need to prove, right? I am taking the LHS, so I keep cos 10 as it is. I have cos 10 plus cos 20 plus cos 30 plus so on, cos 80. Now what about 100? What I'll do is, I'll write cos 100 as cos 180 minus 80, just so that I get an angle of the form 80 degrees, because I already have a term of 80. So I have cos 180 minus 80, then again I'll have cos 180 minus 30, because 150 is 180 minus 30. Then I have cos 180 minus 20, and then cos 180 minus 10. This is equal to cos 10 plus cos 20 plus cos 30 plus cos 80 plus, now what about cos 180 minus 80? That is 180 minus theta, and if you remember, we have just now discussed that in case of 180 minus theta, the trigonometric function does not change, and so it will remain cos, and we will have a negative sign. We have minus cos 80 degree depending on the quadrant in which it is lying. So I have minus cos 80 degree, then I will have minus cos 30 degree, minus cos 20 degree, minus cos 10 degree. Same reason applies in these functions also. So basically what we are left with is cos 10 gets cancelled, cos 20 gets cancelled, cos 30 gets cancelled, cos 80 gets cancelled, and so we are left with 0. So we get the result as 0. The next question says, prove that sine 420 cos 390 plus cos minus 300 sine minus 330 is equal to 1. So again I begin with this side, sine 420 cos 390 plus cos minus 300 sine minus 330. So I can write it in the form of 360 plus theta. So I have 360 plus, it can be written as 60, sine 420 can be written as sine 360 plus 60. Similarly cos 360 plus 30 I'll have. Then I have cos of minus 300, so this can be written as minus 360 plus 60, and then I can write it as sine of minus 360 plus 30. Now we have sine 360 plus theta, the function will remain as it is, and 360 plus theta will fall in the first quadrant, because we have 0 to 90, then we have 90 to 180, 180 to 270, 270 to 360, and 360 plus theta again falls in first quadrant. So I have sine 60 cos 30 plus cos 60 sine 30. So this becomes sine 90. We will be discussing the formula also for this, and still if you don't know the formula as of now, you can just substitute the values of sine 60 cos 30 and you get the result as sine 90, which is 1, and therefore LHS is equal to RHS. We had to prove that this value comes out to be 1, and that is what we have proved. Well, I hope you must have understood about the trigonometric functions as well as their graphs. Now in the next section we will be concentrating on trigonometry of compound angles. That is, we will be discussing various formulae like sine of a plus b, cos a minus b, sine a minus b, and so on. We shall also discuss various questions based on application of these formulae. So stay tuned.